Okay, ladies and gentlemen, since today is an asynchronous day, we are doing our notes via video today. Please make sure that you watch these video notes all the way through so that you can make sure you understand the lesson for today and make sure that you're taking good notes as well as doing the assignment after we're done. So today we're going to talk about how to use probability to help us make decisions. This is actually something that companies will do in order to decide whether or not the product that they are actually putting out for the consumer is the best that it can be and that the company is maximizing their profit as well. So we're going to go ahead and go through this, shouldn't take us long, and then work on the assignment after this is done. The Crayola Crayon Company is shipping crayons in large boxes to other companies for packaging. The crayons in each box should not be broken. The quality control department cannot inspect all of the crayons, so it examines a few boxes from each shipment. A worker inspects 600 crayons and finds that 24 are broken. Based on this information, what is the probability that a random chosen crayon will be broken? So they're telling us that they're pulling 24 crayons out of 600. So we want to reduce that down first. That reduces down to 1/25th. Okay? So depending on how they want you to express it, normally it's a fraction. We can do this as a decimal, and we can also do this as a percent. Okay? So the crayon company is looking at about 4% of their crayons are broken, which isn't really terrible. So that means that 96% of their crayons are good. But to maximize profit, a company doesn't want to have any broken crayons if they can help it. All right? So let's go on to number 2, because this is kind of a continuation of that. The Crayola Crayon Company adjusts its packaging. When 500 crayons are inspected, 8 are found to be broken. So now we're looking at 8 out of 500 are broken. And they want to know, has the probability of a broken crayon changed? This reduces down to 2 over 125. As a decimal, 0.016, and that's about 1.6%. So yes, we've gone from 4% to 1.6%. And realize that maximizes their profit, so now they are able to sell more crayons for money. Okay? So number 3, the Crayola Crayon Company ships 18,000 crayons per week. Predict the number of broken crayons that would be shipped using the old packaging. This is actually proportional. So we know, based on number 1, that about 1 out of every 25 crayons was broken. What they want to know is predict how many out of 18,000 would be broken. So this is a proportion. We're going to cross multiply and then divide. So 25 times x is 25x, and 18,000 times 1 is 18,000. We're going to divide by 25 because that's our coefficient of x, and we're going to find that about 720 crayons should be broken based on the old packaging. Okay? So now we want that same information, but we want to predict the number of broken crayons that would be shipped within a week with the new packaging. So we're still going to use this 18,000, but under the new, it was about 2 crayons in about 125. So how many would you expect out of 18,000? So again, we're going to cross multiply. 125 times x. And then 18,000 times 2 is 36,000. Divide by 125, and x equals 288 crayons. Okay? So again, that's more that they can sell, so that maximizes their profit, puts more money in their pocket. Okay? So what is the probability with the new shipping, that a crayon will not be broken? So if 1.6% is broken, so we have broken is 1.6%, then how much is not broken? That's what we're looking for. So if we have 100% of the crayons that are made minus the 1.6 that are broken, would give me 98.4 that are not broken. So about 98.4% would not be broken. And this is the answer that we're looking for here. And there are a lot of not questions that occur, especially on your SOLs and on your quiz that you're going to have on Thursday. All right, so let's go to the back page of your notes, which is the second page of mine. And we're going to continue with this. So the first question, the bakery inspects a sample of 800 pastries and finds that 12 are defective. Based on this data, what is the probability that a pastry is defective? And by a defective pastry, guys, we could mean that it's not the right size, maybe it didn't get icing, maybe it didn't bake correctly, so that would be considered defective. So 12 out of 800 are defective. That reduces down to about 3 over 200. As a decimal, 0.015, or about 1.5%. You always want to make sure you reduce those fractions down. So number 7 is based on the same information. After altering some machinery, the bakery inspects a new sample of 1,500 pastries and finds 16 are defective. Did quality improve? So now we're saying, okay, 16 out of 1,500, which is about 4 out of 375. So that's about 0.0106 repeating. So we'll say about 1.06. So yes, while it's still not much difference, there is some difference there. So quality did improve. Okay. All right, so our last thing is numbers 2 and 3. I would like for you to try these on your own. So if you take a minute to go ahead and stop the video or pause it for just a few minutes, go ahead and work out problems number 1 and 2, and then we'll come back and we'll work those through together. All right, guys, hopefully you had a chance to work through those. So we're going to go through and do 1 and 2, and that will be the end of our notes for today. A car rental agency rented 343 cars last week. Out of those cars, 3 were returned due to mechanical problems. Predict how many cars would be returned due to mechanical problems if 10,000 cars are rented in a year. So they returned 3 out of 343 cars. How many would you expect out of 10,000? So again, we're going to cross multiply. 343x equals 30,000. We're going to divide by 343. And we get 87.4. Now you can't return part of a car, so we're going to use our rounding rules to round to the nearest whole number. So this is going to be 87 cars. You can't return part of a car. You either return the whole thing or you don't. So use your rounding rules. 5 or greater, you round up. 4 or less, it stays the same. All right, our last one is a cell phone company found 4 defective phones out of a sampling of 500. Based on this sample, predict how many cell phones would be expected to be defective out of 1 million. So there's 4 defective out of 500. How many would you expect out of 1 million? So again, we're going to cross multiply. 500x equals 4 million. We're going to divide by 500. And x equals 8,000 phones. Okay? All right, guys, that's the end of our notes for today. If you have any questions, please feel free to reach out. We have a quiz on Thursday, so please make sure you prepare and study. I do have office hours on Wednesday if anybody needs any extra help. I hope everybody has a great day. Have a good one.